Everybody. This is a video about a quick rundown review of Java itself, what you're going to be getting into, what it kind of entails, some of the software you're going to need, and things like that. So, first and foremost, this class is a class about how to make programs in Java. Now, of course, there's literally hundreds of different programming languages, and they're basically all there to tell the computer what to do. Uh, whether it's load pictures or listen for the person typing on the keyboard or a gamepad or anything like that. But it all starts with, very simple commands. That's what you're going to learn in any basic programming class. All of the basic necessities are going to be in every single program, all the very low level basics. Now, Java is actually, it was originally built by Sun Microsystems. Uh, Eventually, it was bought by Oracle, who owns it right now. Now, it is used on numerous different computers. Uh, it's used on, PC. It's used on Mac. It's used on phones. Uh, you've seen examples of various games and things like that that are actually built using Java. And of course, if you use an Android device, well, that's basically built in Java. There are some minor differences because it's a handheld device than if you was on a PC, but for the most part, most of the coding is done with Java. And there's countless games that are actually done in Java, particularly if you're using a cell phone. Now, one of the biggest ones would probably be Minecraft. Ta-da, there you go. Uh, Built quite a number of years ago, actually, by a guy named Notch, who just basically built a giant world Lego building simulation, I guess you can say, where you can pretty much just build anything you want. And people have built incredibly amazing things. Uh, and of course, you can even install high definition textures and make it look a million times better than the original kind of blocky look. Uh, some of them look downright amazing, actually, even by today's standards. But there have been plenty of people who have built complete cities in Minecraft. And this is done in Java, of course. And you can always download little mods and stuff and make it look nicer if you wanted to. I've seen people build the entirety of like New York City, Manhattan Island. They put it on a server and like 100 people spent like 2 or 3 years building every building to scale and everything. Uh, so you can make an amazing amount of things to it. Most of the time, it's just simply a time waster. You go make a little house, move to a new area, farm, build more, etc. Like most time wasting games. Now, of course, there are numerous games. I think RuneScape is another big one that you may hear from. There's of course fighting games, racing games, and they all look, you know, just like any game system overall. They all look a little different. Some are 2D, some are 3D. It really doesn't really matter what programming language you're writing in. You can pretty much do a lot of the same stuff. Some languages are better for certain things. It just depends on what you're doing. But as you can see. Now, of course, Minecraft gave way to the voxels, which you see in a lot of games now. Uh, and basically, it's just little tiny blocks that are used to build everything. So the entire world was made of blocks. That's effectively what Minecraft did. And now you've got all kinds of little copy cats that kind of use the same thing. Some do it pretty well, others not as well. Just depends. Uh, there are some where you can destroy the ground, cities, build your person one little block at a time. And of course, this uh, can take a lot off of someone who actually wants to make a game. A lot of people get into programming because they want to build games, but it's not just games that you have to build. Uh, there's lots of stuff that goes into programming, not just video games, but for companies, for you know people's personal use. Uh, there's a lot of money to be made if you can just make something for somebody. Maybe a business wants something to keep track of their customers and access a database. There's a lot of programming for that. Gaming and game programming, honestly, is actually incredibly difficult to get into. There's only a handful of good companies, and most of them have been bought up by the bigger companies now. And it's also very seasonal for the most part. But programming overall, I mean, is a huge field because everything requires some sort of programming. Your refrigerator may even have Java programming on it, depending on what it's using. I've seen a computer that had a little touch screen where you could actually keep a list of everything in the computer in the refrigerator. You take things out and it blips, takes it out of the fridge, can remind you of what to buy and stuff like that. Uh, Little stuffed animals with little, you know, that can actually talk back to you and things like that, play recordings. Some of that has programming in it. Programming is literally everywhere in just about everything. And Java is one of those programming languages. Now, what is Java specifically? Uh, it's just one particular way to tell a computer to do something. Now, a computer itself understands what is called machine language, binary. At the lowest level, machine language at its a little bit higher. So it understands those commands. Now, we need some way to kind of talk to it. Machine language is incredibly long and inefficient if you wanted to, make a huge program or game or something. It would take forever. So people designed these programming languages. Now, what you do is you learn kind of this Englishy language to tell a computer what to do. And what it does is you have this thing called a compiler. And the compiler will translate it into machine language. So just to show you a little bit of how this works, let's bring open the paint. Hopefully everybody can see that. All right, so we've got a couple of little bits and pieces here. Let's just run through the how your basic programming works. At first and foremost, our machine understands machine language, and we need to tell it what to do. So let's say this upper box here is my computer, right? And if I can move some of my stuff around so I can see what I'm doing here. There we go. Let's say this is the computer itself. And this would be the code that I'm going to write. In fact, what it's called is source code. So this is the Englishy kind of words that I write. Now the computer itself cannot directly understand what I'm writing. You check the example here. This is kind of what source code looks like. Ta-da. Now you probably can't understand everything here. Maybe some of you can, but the computer doesn't know what that is. For the computer to understand this, it has to have some sort of intermediary translation device in between. And that is where, boop, this guy comes in. This is the compiler. So now every programming language has a compiler. So our source code goes to the compiler, and that compiler tells you if there's any errors or anything like that. It knows all the language and what can be written and what can't be. Once it's done, it translates it into something the computer can understand. So you can kind of liken it to you're sitting here next to somebody from a different country who speaks a different language. Neither of you understand each other. But if you have someone in between who understands both your languages, then they can translate for you. Now, maybe you say something and you mean one thing, but, it gets translated a different way. This happens a lot. It can happen in programming too, where I write something and, it didn't do, I had a mental image of what it was supposed to do, but physically it didn't do that. And that's just something you have to learn as you're programming. All the little, picky things that the compiler wants, prefers. Now, every programming language has a compiler. And that's one of the reasons why it's very, very difficult for someone to, let's say, make a game for, let's say, the Xbox or something, or PlayStation, and then put it on the other system. So let's say this is a computer, right? And this would be my Xbox. And then I'll make another one. Me personally, I actually have only had Nintendo and PlayStations, but there we go. Let's just say PlayStation. Now, each of these systems are computers. They have processors, RAM, video components, and various things like that. And I can write source code for each of these too. So I can just copy paste source code. Now, the problem with this is I can't use the same source code because in between each one of these is a different compiler. Now, each of these systems are different. Their actual, the way they talk, the way they speak, the language they understand is different. So I can't just write source code, compile it on a normal computer compiler and run it on an Xbox or run it on a PlayStation, because there are a lot of differences. So you have to do what's called porting. You have to port this code and change it all so it works with this system's compiler and this system's hardware. And I'm sure many of you have probably heard that that doesn't always work out. You'll have, you know, some PlayStation game, they port it to a computer or something, and it looks terrible. Uh, Things just don't work like they did in the original, because programmers were either lazy or they just couldn't translate it the way it needed to be done. Now, the point of Java is to kind of cut this out. The tagline for Java when it first came out was write once and run anywhere. So basically how Java works is instead of having a dedicated compiler for each system, which means, the source code for this compiler might be different than this one. Let's say even if I use Java or C++ or C# for all of these, if the compiler is different, this may be updated by different people. They add in different features. This one maybe didn't get those features. So now I can't just copy paste and run them on all the systems. So the way Java deals with this is it uses something called a virtual machine. So basically, it's a program that you install on your computer. It's probably already there anyway, called the JVM, Java Virtual Machine. And the JVM pretends to be a computer. It's just a program that sits on your Windows, on your Mac, Linux, whatever device you're using, and it pretends like it's its own computer. Now, when I write my source code, actually, instead of using the normal compiler, I'm just going to cut those out. What I'm going to be using is this virtual machine. Now, the virtual machine may be programmed a little differently, but for the most part, it's the same machine on all of these. So all I have to do, basically, is just install the virtual machine on each of these. And then my source code just has to work on the virtual machine, which basically means I have a Java compiler that I'm going to use. Boop. Box. There we go. And this would be the Java compiler. Or, in this case, the let's see, JDK is what's known as the Java Development Kit. But it's also the Java compiler. Now, the Java compiler compiles for the virtual machine. And the way it works is you install the virtual machine on every one of these systems. And all I have to do is write code for the machine. The compiler compiles it, and it can run it on any one of these things. Now, of course, there is some difference if you have like a cell phone hardware or physical hardware. There might be some minor differences, but for the bulk of the code, Java would be the same. So it's much easier to port and run on different systems. And that's kind of the idea behind Java itself. C Sharp, I think, has kind of taken that idea as well, and kind of copied it. If you ever, get fully into Java where you've learned a lot of it, you can honestly easily do a lot of C sharp because there's a lot of crossover between the two. I liken it to there's Java, C++, C sharp. Basically, C sharp is Java plus C++ kind of had a kid. That's what C sharp is. Uh, Once you learn one language, it's actually not that difficult to write in others, particularly if they're all very similar. Now, that being said, let's see if I can find the programming languages. Family tree, maybe. Uh, Quite literally, you know, for the last, let's say, 100 years or so, there have been programming languages. And some of them have spawned other programming languages. Some of them have just copied stuff from others. I think this one here. And the biggest one that I've seen is, there we go, it's just huge. Like this right here. You see some of the earlier programming languages like Fortran and stuff flows into, Fortran's kind of not used anymore. But they spawned off Algol and a couple of others, Simula, which I used a version of that, I think. One of our teachers did. Objective-C used to be of course, that came from Smalltalk, which came from Lisp, which came from Fortran. It all kind of comes from other languages for the most part. C is one of the bigger ones. Uh, you see C, C++, C Sharp is kind of a mixture of Java, as I said, and C++. You see there's actually lines that are drawn to each of those right here. So if you actually know Java, for example, uh, well, C Sharp, Python, well, Python's a little different, but C Sharp and Java, C++, they're actually pretty similar, and they actually come from the same basis for the most part. So there's a lot of crossover in how you write things. It's kind of like if you learn to talk a language, to speak a language, and there's another language that has a lot of similar words. It's not that easy to learn, or not that difficult to learn another one, especially if there's a lot of similarities between them. And as you can see, Visual Basic, another language we teach here. Uh, but this is just actually a small chart. There's one that would literally take me like 5 minutes to scroll through back and forth. But as you can kind of see, the abbreviated version here, there's a lot. And there's even more than what you see listed here. But that just hopefully gives you an idea of how that works. Now, what you're going to learn is how to write some code and, do some basic stuff in Java 1. As we move on, if you stick with it to Java 2, you'll learn to do more basic stuff. Now, of course, you're not going to be programming games and stuff like that at the end of this class, although you could probably program some simple ones. For that, you'll need to learn a whole lot more. Graphics editing, major big things. And I would encourage you, YouTube is a huge repository of how-to videos. Want to program a simple Java game? Bam, you probably get 1,000 videos online where you can just follow along, build with them. And speaking of building, let's talk about the software you need for this course. So for this course, we're going to be using NetBeans. There is another one called Eclipse, and they kind of do the same thing. What this is called is an IDE. IDE, or Integrated Development Environment. And what that means is basically I can code it all in one place. Now, of course, you could pull up Notepad and write it in that. Then you can, and this is how you used to do it in the old days before they had a lot of good IDEs. You would go to Notepad, type it, save it. You would go to the command prompt, and you'd have to write in the code to run Java. And you would have to write, Java C, which is the compiler, then your code.java, and then what you're going to call it when it compiles, dot blah, 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 blah. And it would run and tell you what errors you had, and it would tell you what line it's on, and you'd have to go down the list and figure out what line. 1, 2, 3, 4, 5. All right, that's the line, that's the error. An IDE just makes it a whole lot easier. Uh, so let's talk about what you're going to have to get for this, or how you're going to get it, rather. Java JDK NetBeans download. Go to Google, type that in. Very first link, and as of this video, it's Java 8, 111 NetBeans 8.2. It really doesn't matter if you're using a newer or older version. Uh, Not a lot has changed, as long as it's relatively recent. Click on that. It'll take you to a page that looks like this. Accept their license agreement, and they'll probably come and collect half of your belongings. I don't know. I never read the license agreement. They might. I doubt it, though. But you'll see we have different versions of this. We have Linux, we have Mac, we have Windows old school if you have an old computer, which I imagine most of you don't, or a newer one, which is the 64-bit systems. And you just click the appropriate one. And what this is going to do is it's going to install the JDK and NetBeans. Uh, and basically you want to do anything else. Now, they can be installed separately, but honestly doing it this way is much easier. You just click one thing, it installs it all, and then you're ready to go. Then we can just use in NetBeans. And I have one version older, but it doesn't really matter that much for the most part. And this is what NetBeans looks like. Poof, there it goes. Now, you'll probably get to a start page. It looks a little bit like this, and you won't see anything over here. I've already opened up some projects and things like that. But as you can see, I can make a new project, and I'll go through that when we start building projects. But I can make new projects. I can open up projects I've already got and look at the code. Now, the nice thing about this is the code is color coded. If I make a mistake or something, it will underline that mistake and tell you that there's an issue here. And we'll get into errors and stuff later, but if I'm missing something, it'll usually let you know. Uh, Whereas the other version where I had to go to the command prompt doesn't tell you until after you've tried to compile and done all the running. This right here is just, I write it, look, no errors. There's even a play button at the top, which you probably can't see, but it's right up here. And it will run the code, like so. And you have a little output window down here to see it. So basically, I can write it here, run it here, see what it looks like. Even if I wanted to use GUIs and stuff like that, I could. I can come over here and add JPanels, JForms. Let's see, JPanel. Just drop it in there, and then I can just drag and drop buttons and edit the code for that if I wanted to. But that's a whole nother class, not to be confused with what we're doing here. But each of these have code and things that you can do with that as well. For the most part, we're learning more about what's under the hood than what the outside of it's going to look like. The way I liken it, for those who've had maybe another language, Visual Basic, for example. In Visual Basic, you learn how to build the outside of a car first, the aesthetics, the graphical user interface, before you really learn to do any of the things behind it. In Java, it's the other way around. We build the engine first, and then we, put the GUI on top of that. I think that's a little bit better, personally, because you're learning stuff that's actually somewhat useful. The GUI stuff can be annoying depending on what you're doing, but it's nowhere near as hard as learning the back-end stuff. And that's effectively what you're going to get. I think we've covered where to get your files, where to get your programs, and if you do run into any problems, you can let me know about installing it. Uh, how to download and install everything. And again, there is Eclipse, but I'm going to be using NetBeans for this class when I'm showing. The errors are a little different. I mean, it's still going to do the same thing. It's just that the error messages you get will be different. So playing with both isn't bad because Eclipse is really good for, it's got a lot of built-in stuff for like mobile programming and stuff like that. There are several versions of Eclipse that are strictly for like Android and programming and things like that. But this is a good starter because it will show you a lot of little errors and little issues. And once you play with the others, you can start translating this error. Oh, it's the same as this other error. It just says something slightly different. But they work the same way. But that's your software. That's basically what you're going to see. Any other questions or anything like that, just let me know.